So welcome everybody in this session. So today in this session I'm going to discuss about one new concept that is called the Azure Durable Function. So it's basically the stateful workflow on the basis of stateless architecture. So we'll discuss on this subject concept and also demonstrate how we can develop Azure Durable Functions by using Visual Studio or by using Azure Portal. So about me, I'm Debasis, working as a solution architect in Microsoft Pune, and also simultaneously I'm a Microsoft certificate trainer and MVP. And I have around 12 more years experience working in a development IT sector on different technologies. So in today's session, we will discuss about different topics related to the Azure functions or Azure durable functions. So we basically discuss about the basic concept of serverless architecture and also discuss about some basic overview about the Azure functions because Azure durable function is basically a part of the Azure functions or a extensions of Azure functions we can say. So once we going to develop Azure durable functions, we need to understand about the basic concept of Azure functions, how it works. So we'll discuss first about the basic concept of Azure functions, and then we'll discuss about the Azure durable functions related functionality, and why we need to use Azure durable functions or what are the benefits. And also when we define Azure durable functions, we have different types of, we can define different types of Azure durable functions. So we'll discuss about those different function types and also the different applications pattern which we can follow during the implementation of Azure functions in our real life project. And at the end, we'll demonstrate how we can develop or implement Azure functions with the help of either Visual Studio or Azure Portal. So at the beginning, we first understand the concept of serverless architecture. So serverless architecture or serverless technique is basically normally known as the cloud-based architecture. Because earlier, when we are involved in the development, and in that around 5 to 10 years ago, we are normally involved on the development related in our desktops or desktop computers or server computers. Where if we want to develop any application, first we need to develop those applications in our own desktop machines, and then after completion, we need to deploy those applications in a particular server. Obviously, that server is a physical server which contains either our client's company or which company owns it. So as a company, they need to maintain the entire hardware and infrastructure for that server, and they need to maintain. But once the cloud environment concept is appear or this serverless technique is introduced in the industry, from then we are also need to maintain our server type infrastructure for our own because we can use the cloud-based infrastructure for our applications and directly deploy the applications in the cloud-based architecture. So that is the basic concept of the serverless technique. So in case of serverless, it is a basically cloud company execution model where cloud provider basically provides us a dynamic servers in which we can deploy our applications for our users and maintain it. So in basic terms, we can say that in serverless techniques, actually there is a server. That serverless techniques does not mean that there is no server in the entire workflow, but basically there is a server, but that server is basically maintained by the provider, not by us. So that's why for us, it's a serverless architecture. We also need to worry about the infrastructure or server configurations or upgradations of the server or scale out, scale in different this concept. Provider always maintain this infrastructure and upgradations and everything. So this is the basic concept of serverless architecture. So serverless compute is basically act as a either as a function as a service or as a microservice, which can be hosted in a cloud-based environment. So function as a service means we can develop a function or a block of code as a function and host it in the server layer, so that that particular block of code can represent our business logic and can act independently. So our business logic can run as a function, or here a function is basically represents a block of code or a workflow or something like a implementation of some business calculations or business process implementation. And we don't have to manually provision or scale out the infrastructure. We just need to implement the code in the cloud environment, and then the rest of the other infrastructure related headache will need to be maintained by the service provider of the cloud, that is either Azure or AWS. So the cloud provider basically manage the infrastructure which is required for running these functions or running this microservice in the cloud environment. What are the infrastructure, and when we some scale out or scale up or scale down is required, it will also be maintained by the cloud provider. So our app is automatically scale out or down depending on power load. So that this is another benefit. And in this concept, once we consider for the serverless compute concept, so we can develop or implement in two different ways. One is Azure Logic App. So Azure Logic App is one type of serverless compute, and another is Azure Functions. So today's in this session, we mainly focus on the Azure Functions, not on Logic Apps, but yeah, definitely using the Azure Logic App, we can also implement the serverless compute concept. So before going to in discussions in details about the Azure durable functions, we first need to discuss some basic idea about the Azure functions. What is Azure functions? So Azure function is basically represent a serverless applications pattern. So when we need to develop any business logic or any business-based process, like suppose as example, suppose if we want to implement one approval process for our own employees related to their leave or holiday. So we need to implement the entire workflow in our code, and that entire boilerplate process we need to maintain. But in case of Azure function, we simply need to implement only write down the codes related to that business logic or approval process related sections, and put that code as Azure functions in the cloud Azure environment, and then it will automatically work. We does not need to create the entire or follow the entire process of the development cycle. So it enables developer to host any types of business logic that can be executed without any provisioning infrastructure, because at the end, each and every Azure function provide as a depends upon an event-based trigger concept, and it provides the URL. So that URL can be accessed from anywhere or can be used from any of the mediums. The functions provide basically instant scalability, and we are charged only for the resource bit. So whenever we use in any cloud-based environment, costing is one of the major points. So we need to consider or think about the costings of our implementation. So maybe suppose today I have hosted a one Azure functions in the cloud environment, but in the next 10 days, nobody is used that Azure function, because maybe that functions usage will be start from the 1st of June. Okay, but for safety purpose, we are hosted for that functions today. So we does in this scenario, we need to pay a very nominal cost, most probably negligible or cost for this duration while this Azure function is not used, because in case of Azure functions, billing only charged when the resource is used by the user. So if the Azure function is used by the user, then only billing is charged, billing cycle is activated. Otherwise, it will not charge any billing. So if we create a Azure functions and app functions app and hosted in the Azure cloud environment and keep it ideal for next 10 days, then it will not charge me on daily basis rate. It will maybe give some nominal $1 or to $5 charge for a 1 month for using some common resources like resource group or some network. But actual charge of the functions once the user starts using, then that costing model will be activated. And another benefit of the Azure function is that we can write our Azure function in different languages, because Azure functions provide or support different languages like C#, X#, JavaScript, Python, and PowerShell. These are the right now supported languages by the Azure functions with which we can develop. And also, if we require, we can install NuGet packages or NPM installer or NPM packages for our Azure functions by using the Azure portals or our Visual Studio, so that any third-party JavaScript library or any NuGet packages is required for running that Azure function, those can be used. So Azure function is basically depends upon the triggering concept. Triggering concept means Azure function does not invoke itself. So once the Azure function is created, we need to invoke or trigger that Azure function to execute. So that executions either can be against by a particular event or from against when any particular user hit the URL like this. So we can consume that Azure functions URL in our any existing applications, so that once that URL is invoked, that Azure functions workflow will start automatically and start work. And similarly, Azure functions can work as an input binding, that is, it can accept the data from the input as the input data, and also as the output, it can return the data. So it totally provide binding concept, input and output binding. And Azure function is definitely as in the cloud platform, it also support the cross-platform environment, and it's basically the open source. So this is the basic concept of Azure functions. So after the Azure functions, we need to discuss about or know about the Azure durable functions. So Azure durable function is basically is an extensions of Azure function. So if Azure durable function is not a different part of the Azure functions, but it's basically the extensions part, because Azure function is basically provides us a stateless architecture where we also need to maintain any state of the application. In some scenario or some real cases, we need to maintain some state value during the entire process. One, because Azure function is normally represented as one single event, but when some entire workflow or some event is dependent on any other event, suppose as a change sequence, suppose if event function 1 is executed and then function 2 will be executed after the complete execution of the functions 1. So you have two different functions, say function 1 and function 2. And suppose once function 1 is start executing and once it completes the execution, then as per the output of depends upon the output of the functions 2, function 1, functions 2 will be executed. So in that case, the entire chain process needs to be maintained at value. That what is the input value of functions 1 and then what is the value in output value of functions 2, so that functions 2 can accept that output of function 1 as the input and can process and further and give a final result. So in some scenario, we need to maintain some state locally or during the workflow. So in that case, Azure durable functions will act as a key node. So Azure durable functions basically operates uses or operate mainly for a long-lasting stateful operations in Azure environment and provide a stateful function workflow in a serverless environment. So stateful function workflow means because it basically is provide a long-lasting environment. Like if suppose one single process, if I need to run one single process, like say once that functions is executed, we need to calculate or process the data and accordingly need to finalize the final output and store in the database. If this is the scenario, then Azure durable function is not a good selection for this scenario. Azure function is the best for it. But if we have multiple steps of operations, like say, as I said earlier, that suppose we need to implement the employee leave approval process. In that case, we have a different scenario. Like once the employee apply for a leave, that leave approval needs to go to reporting manager. Now, reporting manager can approve the leave or can reject the leave. In that case, the related employee needs to be notified that either their leave has been accepted or rejected. Also, maybe the reporting manager can not approve the leave within say 1 week times the next 1 week, and in that case, in a company we have a one rule that within after applications within the 1 week, if reporting manager is not approved that particular leave, then it will be escalated to the next level. So there are different types of reactions. In this case, Azure functions will be a good choice, because whenever we need to use the Azure durable functions, we need to use this type of long-lasting operations, which may occur in a long period of time. But entire process will definitely not run during the 10 days. But yeah, the entire workflow will require the complete to maybe 10 days duration. And the entire workflow may contain several steps, and each and every step is dependent to another step. So in this case, Azure durable function is one of the best choice, because in this process we can store the state of the events or each and every step, and accordingly next steps can be performed. So Azure functions is always taken data from input parameters, process the data, and performs the appropriate actions. This is the basic operations of the Azure functions. But in case of durable functions, instead of using a single function, it always takes a series of functions. So in case of durable functions, always we require at least more than one functions required to implement it as a durable function and act as an entire combination. All the functions will be act as a single unit, then builds in the workflow to manage the actions, and in the workflow will mentions how the functions flow will occur. That is after one execution of the one function, which function is to be executed, and that calling we need to call. And accordingly, it will wait for the entire execution, and after that, it will find output giving us the final decision. So this is the basic difference of the Azure functions and durable functions, because Azure functions is always takes as a single input, process and give an output. And once the output is completed, the Azure functions workflow or process lifespan is completed. But in case of Azure durable functions, it always acts as a unit of functions, a group of functions, and it will act as a unit, single unit, and entire unit needs to be completed. So maybe that completion time span of an entire unit may be more than 1 day or 1 week or 1 month. That is depends upon our workflow definition. So these are the in case of Azure durable functions, what are the benefits we can achieve? Because Azure durable functions basically provide a functioning model which is very simple and flexible. We can define different types of functioning model. Using Azure durable functions, definitely we can support the rapid and simple development, because we can write down the code in the Azure portal, and we can does not need to follow the entire boilerplate process. And also, as a durable function, as the extension works as the extension of the Azure function, so it is also a cost effective, because we need to pay only when we use the functions. If we are not using the function, it does not need to pay. And there is no server we need to maintain. Azure infrastructure or Azure domain or cloud environment automatically to maintain the scaling mechanism of this Azure function. So once they require, they scale up or scale down the environment. And all the powerful apps can consume the Azure function like CI, JCD, window, easier, certificates, custom domain settings. All these types of app settings can be implemented in case of Azure functions also. So obviously there is a question will appear that why we need to use the Azure function. So in case of Azure functions, it basically provides the event-driven mechanism. Durable functions can wait asynchronously for different external events during the execution process, and then after the execution external event completion, it can perform the next task or a series of tasks related to that particular event. So it does not need to invoke any manual intervention for this process, manual intervention. We can define our own workflow. As per the definitions of the workflow, it will work. Also, we can maintain or manage our workflow state. We can implement complex workflow without using database to maintain the state. For example, if we want to use database, we can use it to update the state of our business entities for tracking purpose. But in case of Azure durable functions, we does not need, because our orchestration process automatically acts as a database concept, and it will handle its own work. And also in case of testing and debugging, when we developing any Azure durable functions, as we can develop the Azure durable functions by using different programming ID in our local environment. So easily this can be tested and debugged locally before finally deployed in the cloud environment. If we want to test and debug in our local environment, and then only we can want to deploy in the cloud environment, that can also be possible. So for development, we can use different types of programming ID for developing the Azure functions or durable functions like Azure Portal, Visual Studio, Visual Studio Code, Visual Studio for Mac, Intelligence ID, or Eclipse. These are the different IDs provided the support for defining the Azure functions. By default, Visual Studio provides the Azure Functions template, project template, but in case of Visual Studio Code, we need to install the extensions related to the Azure Functions, then only it can be work. So once we are trying to develop any Azure durable functions workflow or process, we need to understand the different types of Azure functions. So in Azure functions, durable functions, there are 3 types of functions you can define. First one is the client function. Client function is basically the entry point of an of Azure durable function workflow. So it acts as an entry point. It helps us to create an instance of the Azure durable functions orchestrations, and it always can run as a response of any HTTP request or event event. So we can write and develop these client functions any supporting language. Basically, this client function is the act as an entry point, and this entry point client function is basically invoke the main controlling orchestration functions of Azure durable functions. So these functions can be developed in any languages which supported for the Azure function. And the next function type is orchestrator function. It basically acts as a controller of the entire workflow. So it basically describes how the actions will be executed and maintain the order of the function execution. So if the Azure durable functions contain 10 different function states, then orchestrator functions is basically maintain that entire workflow sequence, and that once one function is completed, then which function is to be created, called, or on which way. So if there is a input wise, output wise any dependent, if output value is true, then on this function needs to be called. If output function is false, then this function needs to be called. And that those business logic also need to be implemented in orchestration function. And these functions can only be developed either we can use as per right now, we can develop these functions either using C# or JavaScript. F#, Python or PowerShell code script is not supported for orchestration functions. And the next one is the activity function. Activity function basically acts as a unit of work within the durable function. So it acts basically, each and every activity functions act as individual unit which can perform a single task. And once it's completed the single task, it returns the response to the orchestrator functions, and orchestrator functions collect their response, and according to the defined definitions of the workflow, it decided which next activity functions needs to be invoked. The activity functions contains the work performed by the orchestrator function task. So these are the basic three types of orchestrator functions. So once when we going to develop any Azure durable functions, we can implement the Azure durable functions in different patterns. One of the default functions pattern is the function chaining. Function chaining is basically the one-liner single 1:1 flow sequence. So this image will clearly explain that how it will work. Like there are 4 functions defined. So once the function 1 executed, it send its output to the function 2 as the input, and when function 2 is start execution. Again, once function 2 is completed, it provides sends its output as the input to the next functions, and this way it continues to work. So if function 1 execution takes 1 day time, then it will wait, and once the function 1 execution is completed, then it will send the output to the function 2 as the input. So this is the normal chaining function. So we can define the workflow just like this as per our requirement, and this entire workflow needs to be defined under the orchestration function. This is the one approach. Next, another approach is fan out or fan in approach. So in this approach, once a function is executed, then that input functions, that function's output is sent to the multiple functions as the input, and that first function's output will be sent as input of a multiple function, and those all the functions will start execution parallel. Once all the functions execution is completed, orchestration functions receive all the results output result from all the functions, and on the basis of that result, it finalize the entire final result and return to the next function or to the user. So this is the one is the fan out or fan in. Fan out or fan in process, multiple functions can be used. So in this scenario, this F1 is act as an entry function, and this entire process, this each and individually, these 3 functions is basically, or F2 functions is act as an activity function, and this entire process, this entire work process is basically maintained by the orchestrator function. Another pattern of Azure functions which rarely we use, that is async HTTP API. It basically depends upon the status of the work. So this pattern can be applied to solve the problem of communication state for a long-running operations with an external client. This So concept we only require when we require to communicate with external client or any external resources, and which that resource or that process can be run in a long time span pattern. So in that case, then one HTTP call executed for long running workflow, and each and every time Azure functions after a certain time interval, it checks the status of that long running process. Once the status is completed, then it will move to the next one. Otherwise, it's still keep waiting. So another, say we can say that this is the last process or last pattern, that is the human interaction. Human interactions means sometimes we require to implement some automated approval process. So automated approval process means once a request is generated, that request is sent to a particular person. So now the request approval is basically depends upon that particular person's availability or time frame. So in that case, systems need to be wait until or unless that particular person is wants to accept the request or cancel the request. Anything. But if we require, so this is called a manual intervention. The manual intervention means once the request is raised, it send a communication to any particular person via email, SMS, or something, any notifications, and system is still waiting for the response of the notifications. Once the person is accept the approval request, then it will process the next layer of activity. Or if the person rejects the request, then will process accordingly. But suppose if the person is not available and will not approve or reject anything, will not experience anything for that request, and in that case, we can set a time interval that within the next after sending request within the next 5 days, if it is not approved by the requested person, then we can escalate the same thing to the next level of person or another person, so that they can approve or reject that process. So that escalations can be occurred. So in that case, we need to use some timeout interval or timer concept in the Azure process management. So this can be one of the real-time requirement when we implementing some Azure functions. So when one is going to create Azure functions, we can first I'll explain how we can create Azure function by using Visual Studio. So right now I'm using Visual Studio 2022. So once we open the Visual Studio and click on the create a new project option, in the project template Visual Studio 2019 or 2022, it provides a project template called functions, Azure functions. So we need to select Azure functions if we want to create Azure functions or Azure durable functions. So we need to create Azure functions and then click on next. Right now, and then we need to provide the functions name, say, provide the project name and click on create button. So once I click on the create button, it will provide me up to two options for which framework we are going to create this Azure function and which type of Azure function template we want to use. So there are different types of Azure functions template is available. So here by default, Azure functions provide .NET Core 3, .NET Core 5, .NET Core 6. So since I am using the VS 2022, so .NET 6 is available. So I can select .NET 6 or .NET 5 also. But when we are going to portal, sometimes .NET 5, if we are trying to hosting this application, so it will be better to select either .NET 5 or .NET 3 because some of the functionalities in .NET 6 still not accessible from the Azure portal directly. So I'll select .NET 6 right now, and not because I'm not going to host this part. And here there are different types of Azure functions template is available. There are different types of Azure functions template. All are the Azure functions template. So if we want to create any types of Azure functions, then we can select different types of Azure function template like HTTP functions, base functions, HTTP trigger with OpenAPI, block trigger, timer trigger, etc. But as we are focusing to work for the durable functions, so I'm selecting Azure durable function orchestration, this template. So once I select this and click on create button, it will basically scaffolding a sample function structure here. Also, if we are familiar with defining the Azure function structure, then we can also select the empty of template of. Then it will simply create a single file, but we need to create all. So just for time saving purpose, I'm selecting the Azure functions orchestration, and then after that we will modify the structure. So now I click on the create button. So it will by default create 3 functions. So it will create 3 different functions. This is the coding pattern or structure pattern of the function. So when we create a function, we need to provide the attribute function's name and object related function. And each and every function can take except input parameter and output parameter. From these functions, there is a one function called HTTP start. It is basically act as an entry function. So once we run this function in the browser, first this function will start executing, and once this function is start executing, or once we read that particular URL from the using from our browser, it first focus here, and then it start executing the orchestrator function. Orchestrator function means this is the orchestrator function, run orchestration. And within the orchestrator functions, we can define call or execute multiple activity functions which we have already defined. Just like here, we have already defined one activity function, and that activity function we have defined here. And that activity function is called here for multiple tasks. So if I will make some changes in code. So for that purpose, I add one class file here, because we are going to define some custom input for the function of the activity. Run. And then I simply replace the port of this. So as per the example, this function is also contained by orchestrator functions, which calls multiple activity functions. Here I am creating 2 activity functions. So which function is activity function? It is denoted by using this activity trigger attribute. So if the particular function is used by activity trigger, that means it acts as an activity function. So I am using 2 different activity functions. One is to say hello, and maybe your function's name and actual function, your function key name and function method name may be different. You can use the same name or you can use a different name. That's not a problem, because ultimately when you hosted this function, this name will be act as a output. This function name will not available in the outside world. And also there is another function called HTTP start, so which is basically act as an input function. So within the orchestrator functions, I have defined one output list, and within this output list, we have defined the input parameter, custom input parameter, and then pass the different types of value to those activity functions one by one. And then we receive all the data as output and so on. So it is basically one of function chaining concept. So one by one functions will execute. First will execute this function. And actually here we are calling the same functions multiple times. Simultaneously, we can call this can define 4 different functions and can call one by one as per their input. And also we can receive the output from this function and send that value as the input to this next function also. So I'll just simply run this first build that. So to the first time it will take some downloaded the related packages. So rebuild successful. So we'll click on start debugging options. So it will first open in a console here. And once Azure functions start executing, it basically provides us a URL, simple URL. Each and every NP function, Azure in durable case functions, each and every NP function is basically represents a provides a URL just like this. So we have defined 4 different functions. There is the output of the functions which we have defined. So we have defined one orchestrator function, 2 activity function, and 1 HTTP start function. But orchestral functions or activity functions does not provide any URL. Only HTTP functions will provide us URL, and this HTTP method can be accessed as a GET or POST HTTP path. So we need to copy this URL, and we simply click this URL to copy and paste in a Postman. So I'll copy this and paste here. I'm selecting the HTTP. So just and then click on the send button. Once I click on the send button, it provides me a query status URL. The status URL send event post back URL everything. So there are different URLs. So once this function is executed, it will each and every HTTP function return 2 types of URL. That is, what is the status get URL, event post URL, terminate post URL. They are different. So as per our activity or requirement, we can consume this URL in our application. So I'll simply click the status query URL, and once it will open in the new browser, and I'll click on the send button because it basically is a get URL. And in that case, it will give me the output that each and every activity function is executed and stored as the int. So now, if we put some breakpoints, suppose we need to validate for which sections will first executed, either activity function or HTTP function. I put the variable and then first click on the first URL. Yeah, so click on the send button. So first HTTP functions is executed, and then I'll put other 2 functions breakpoint. So once this function is executed, started, and then it starts calling it internally. It calls the orchestration function, and then orchestration functions start calling as per the workflow definitions one by one. We start calling the next another activity function, and again once that function is completed, once the function execution is completed, it start parallelly call the functions asynchronous process one by one. So it starts the one by one methods, and at the end they return back to us and all the call is asynchronous and collects all that value here and return us to the status query function. So once we click on the status query function, it gives us the output as per the expected. So in the output part, we can receive the output. And so at the same time, we can find that what is the status of the entire workflow, either it's currently running or not, is there any input or not, or is there any output. So this entire time frame we can identify it from the status query. Similarly, we can define another function. Suppose I'm going to create another function. So I simply add another file name, right? Add new actual function. The function name is function2. So here, similarly, it asks us the same type. So now, suppose I'm going to select the same options, durable function of the type, and set. And once it is created, I'll remove all the scaffolding code because I don't want to use this scaffolding code. So here, similarly, we have defined first entity functions and 3 activity functions I have defined here, and one orchestration function. So orchestration function is basically does not accept any input from the outside world. It starts execution. And once the first orchestration function is executed, which is basically is a fan out execution process. Once it starts execution, it first called the function one. The function one is basically return some series of number, an array of number to the as the output. So once it receives the value as the output of list of number array, then on basis of this value, it start calling the second orchestration activity function, that is the F2, and all the values is passed parallelly in F2 function. So once this all the value passed to the F2 function, and in this case it will not return anything, it will not doing anything, it simply collect the value and return back me the same value. But yeah, definitely we can perform some business calculation here to implement some business processes under this F2 function. And after the return value, we simply add those values under an array. And once this all these value we have received, we calculate a sum result, and then we return this value to F3. F3, after receiving the value from after the sum result, it basically multiply the value by 2 and return back to us. So that will be resulted as the final output. So now just build out solution. HTTP 1, because the function name must be unique across the entire project, because I have already another function called HTTP in function 1 method, so that's why it gives me the build error. So now the build is successful. So this is the function name. So I just simply run the entire process. So now it will show me the so there are two URL which is provided. First one is the HTTP start, which is the earlier function related URL, and the second one is the HTTP start one. And the rest is the information that what are the, how many activity functions or functions we have defined. So I return back to the Postman and change the URL to HTTP start one and click on the send button. And it will return me the status URL. So I simply click here and click on the send button. So it will return me the output as 100. So we need to calculate either output is 100 is correct or not. So there we have stored 5, 10, 20, 15, 30, so 50. So 50 multiplied by 2, that is 100, 600. Suppose I have added another number here. I have multiplied it by 4 times. Now we need to check either the result is still same or not. So I will first again hit the API and close the PDF index and hit the startup page. So the right now the output is 600. So the total out is 150. So 150 is multiplied by 4 times. So that's why this is coming as 600. So this is the example of fan in, fan out, where one activity function sends us some output, and on basis of that output, other activity function is processed, and after as per the output of all the parallel activity functions, the final activity function calculate the final result and return back to as the output. So this is another example of fan in, fan out. So if we want to host these Azure functions in our cloud environment, then we simply click on publish here, and we can select Azure environment, then click on next. And then we need to define which container or which type of environment we need to use for this, either Azure function as for Windows, or Azure functions are for Linux, or F container or registry. So you can select any one of them. So I click this Azure functions are here. And then we need to select the subscriptions. Accordingly, we need to select the resource group. If we have a existing resource group, we can use the resource group, or we can create our own function set, because I have already created one function set for this demo purpose. So we can use that function set, or also we can create our own new function set. So in the new function set, I can select for a demo and remove these numbers. We can use our already existing resource group and then storage, and then click on the create. It will take some time to create that function set in the Azure environment. 2 to 3 minute time will always take. So once it's created, we can select that functions app and simply click on publish button, so that it will publish the app Azure functions in our Azure environment. So okay, let's keep it creating. So I'll return back to the Azure portal. So in Azure portal, we can also, from Azure portal also, we can create a function set. So Azure portal from resource group, once we click on a create a resource, and here if we search for the function set, we can find that this is a function set. We can get a function app options, and from there we can create the functions app. So once we create the functions app, wanting the functions app, we can select the resource group or available resource group, or any can select any resource group. Need to provide the functions app. As per that, we need to mention that how we want to deploy it, as a code or as a Docker container. If we select the code, then we can develop the functions by using the Azure portal. And if we're using the Docker container, then essentially we need to deploy the Azure functions from using the Docker Visual Studio or anything. Runtime, we can select different types of language: .NET, Node.js, Python, Java, PowerShell. Anyone which in language which one we are comfortable, you can select any one of them. Suppose if I select .NET, then it will provide 3.1 and 6. Right now 5 is not provided. If we select Node.js, it will provide us 12, 14, and 16 LTS versions. Similarly, in case of Python, it will provide 3 version 3.7, 3.8, and 3.9. So once we select all the things, and then we can click on the review and create button, and to create the function set. For the time save purpose, I have already created one Azure function here, and I have selected the technology steps as a Node.js for developing this Azure function in the cloud environment. So once we create the Azure function, we need to, in a Node.js environment, we need to first install the npm packages. Also, we can install some custom npm packages. So if we want to install npm packages, so we need to open the app service editor. For that, we need to search the development tool options, and there we have a preview option called app service editor. Right now it is in preview, but we can use it definitely. So once we click on this and click on the go button, it will open the app service editor. So this is the app service editor. As I have already created some functions here, so that's why it will by default displaying all the functions. But initially, when you first create a Azure function as function app, then only it will select the www root, and under this root only one JSON file exists, that is the host.json file. And here you need to create a package.json file by right clicking and click the new file options like this, and then within the package.json file, we just need to add the JSON structure. What are the JSON structure? And after that, after adding the JSON file, if you want to install some custom NuGet packages, then you can run the related npm command by using the console in the functions app window. So once you click on the console, it will come to the same root position which is provided here, and we can install it npm install what is the by default commands of that particular package, and we can install it like npm install say bootstrap. If we install it, so it automatically installs the bootstrap under the node module package under this folder, node module folder, and added the related packages under the bootstrap already added, and accordingly it's installed. So this can be done. So after that, we need to create a function. So for functions, we need to click on the functions option. And once the functions option is available, we need to click on the create button. And once we click on the create button, there are the different types of function template is available, just like Visual Studio. For durable functions, it can filter out the function type. So in Azure portal, there are 5 different types of durable functions template is available. One is durable function HTTP starter. This is the entry functions which always need to use. One is the orchestrator functions and the activity functions. And if you require to define some entity, then you can use the entity functions or entity functions related HTTP starter. So these are the 5 different templates we have available. So I have already created 3 different functions. One function is related to the HTTP functions, that is the durable function HTTP starter. One I have created, that is the orchestrator function. This is the orchestrator function, and another is the activity function. So these 3 functions I have already created. So if I want to check what are the codes I have written under this function, so I need to navigate to these functions simply, and then click on code and test plus test options, and it will open that this function JSON file in a code editor, and we can view the existing code and also alter the code. So we have simply called as this, just like default function. We have simply added, and simply in case of leave approval process, I have added one single line that return a status message. So I simply returning a status message. And in case of orchestrator functions, I called the leave approval status message 2 times. So for the first time, I have sent the status message as approved, and another is a reject. So simply calling a chaining type process. So I can call any one or I can call. So this is a concept of Node.js. So after that, if I don't want to execute this function, I need to navigate to the HTTP function. And once I navigate to the HTTP function, the status bar provides me a function URL. So I need to copy this function URL, and I open the. I just open a notepad. So very carefully. See, this URL is demonstrated like this, and here one parameter is given by the function name, because when we define this function by using Azure portal don't have any idea what is the orchestrator function's name, because once we run this function from using Visual Studio we can define that function's name within Visual Studio. So it is already created, so I'll just click on finish button. I will deploy it later. So here we can provide the function name directly, that this orchestral function is to be executed. But in case of web portal, we can run multiple orchestration functions. So that's why it will not provide any function name directly. So we need to provide the orchestration function name manually at the time of execution. So I will simply copy it and paste in place of this. And now we can copy this entire URL to the browser and run this. So similarly, it will return me the same type of response. So I need to simply copy the status and paste it. So here it will basically display that your applications, or if I run it from the postman, then it will be the trend, then it will be presented. So this is the input. If we want to place our orchestration functions name within the HTTP functions, then we can provide it within the code part. So once this code part is there, so here it is giving us a parameter called function name. So it can provide this function name as a directly. And simply. So now click on this code. So function key. So it basically always defined this way. From Visual Studio, we can directly host it this out directly. So this is the example. So once it is in Visual Studio, once the function is created, we can simply click on Publish button, and it will automatically publish that function in Visual Studio, and that same functions is available under. So if I go to the practice demo section, I can found that there are two functions as I defined. One is the earlier one, which I have already created from the portal, and this one is created from the Visual Studio. So if I go to the function, there is no function is available. So once I publish it, those functions will be published in the portal. But if you publish any Azure function by using Visual Studio part, then we cannot edit those functions by using Azure portal, because in that case, those functions will be deployed here as a DLL concept. So if we want to deploy it or make the modifications or modify the functions, then we need to done from the Visual Studio and then deploy it again. Take 1 or 2 minutes. Yeah, deployment. So now so all the function is already developed. So functions in which we have developed. So if I navigate to any of the particular functions, we cannot view the code block. We cannot edit this code block because those functions is basically deployed from the Visual Studio. So this is the DLL, one type of DLL function that is given that this is a DLL part implementation, so you cannot change it. So if you want to make any changes, you make those changes here and then again redeploy. So this is the overall concept of Azure functions. So we have some three types of demo, and that's all from my end for today's session. So now if anybody has any query, they can ask.